Here they come. We'll just let people trickle in a little bit. We usually wait a couple of minutes and then I'll do some introductions and we can get going.
Okay, great. Excellent.
And if anybody has questions, feel free to chat them on the side and we'll address them at the end.
Okay.
Great. Great. All right, I think we'll get started. So hi everyone, welcome to our Thursday afternoon webinar. I'm Joanna Roach and I'm the Executive Director of GSN Planet. Megan, the lovely Megan, is over here handling the controls. Megan's our marketing manager. So thank you for manning the controls again, Megan, this week, 2 times. And we also have Tony Abate, who is the CTO of AtmosAir. So welcome, Tony. We are really very excited to see you and hear from you today.
Thank you very much. I look forward to sharing with yourself and the audience.
Great. So this is what sort of has transpired and how I know Tony is that I was introduced to AtmosAir, I don't know, 3 or 4 months ago by a colleague and have sort of been looking at them as a tech partner for GSN and really wanted to understand their technology and how it worked and have kind of had the opportunity to talk to Tony about it a couple of times, and he can give a really clear and concise and great explanation for how this technology works and why it's important for these times. So Tony's going to make a presentation today about AtmosAir and about how his ionization system works to clean the air. And so without further ado, Tony, I think what we'll do is let you do your presentation, and then if we have questions, we can ask them at the end. Okay?
Thank you very much. And I'm going to kind of take control of the screen so I can share some slides that we have. Just go, don't judge me by my desktop. But at any rate,
oh, mine looks the same.
I just want to confirm you can see my slide here that says the air is better here.
Yeah, we can see it.
Great. Okay. And I'm going to hop around a little bit here. So this first slide is a little introductory about our company. We started actually in 2004, where we discovered this technology that had been very prevalent in Europe. Again, my personal background of being in indoor air quality testing and analysis and running a company that was doing just that, looking at possible solutions and how could you improve air and how could you fix air quality problems, came across this technology which had been used for many years in Scandinavia, which actually has an extremely interesting story. It goes back to collaborations between Albert Einstein and somebody by the name of Conrad Habish, where they talked about the presence of a natural conductivity in the air, and that conductivity was discovered to be air ions. And I'll explain a little bit more of that as we go on in the presentation. So we bought the technology from the European company and went about developing it, filed many different patents, and branded it AtmosAir. We since then have grown our company. We have partnerships with some very large players like Johnson Controls. We've done some very big applications like the US Bank Stadium and the Staples Center Arena, LAX Airport, places large and small. We can do an application such as a single hotel room, which we do for the Hilton, and all manner of in between. So we've been doing this for now 16 years with 7,500, and that's probably dated, it's probably over 8,000 installed systems. And again, offices in Fairfield, Connecticut, which is my location. But we have an office in Tempe, Arizona. We have an office in Dubai. We have an office in Shanghai, China, and we have some pretty substantial manufacturing partnerships that give us a lot of capacity to help a lot of people. If the audience goes to our website, atmosair.com, there's an interesting video, an animated video that the architecture firm Gensler made on our behalf. They're an enthusiastic supporter and user of our technology. And if you just want a quick 2-minute video on what our technology is and how it works, it's a great thing to visit and to see. Again, we've done lots of applications for lots of names, you know, and lots of different types of environments. And just look down here on the left, all of those markets are markets we've served with this technology. And again, some very high profile clients with this technology. Okay, so what is this technology? We make systems that cause the formation of positive and negative air ions. Our systems integrate with the building's air conditioning and heating system. That could be for an area as large as the Staples Center, but it could also be for your home. Wherever conditioned air gets supplied to, we infuse it with these ions. The ions then are distributed into the occupied space where people live and where they breathe, and they can go about performing air cleaning, but more importantly, air sanitization of the space. And I want to kind of detail that a little bit more. So I'm going to start talking about the thing I think that's on most everyone's minds, and that is microorganisms, viruses, the things that can make us ill. Obviously, coronavirus and COVID-19 is dominating our thoughts over the past few weeks. What ions can do is disrupt the surface membrane of the virus. When they do that, the virus becomes breached. When that occurs, the virus is unable to reproduce and spread and infect, and essentially is deactivated or neutralized. And there's a very highly scientific way to explain that, but that is the general explanation of what the ion does to a virus. What's very interesting and unique about our systems is that they're not trying to bring the contaminant to the unit to affect it like a filter or a passive system might, but rather they flood into the occupied space and they don't necessarily care where the contaminant is. They just are attracted to it by the opposites of attraction charge, negative to positive, and they perform this neutralization. So this contaminant could be in the air, but it could be lying on a surface. And with the coronavirus and COVID-19 in particular, most of the transmission is from expelled droplets or direct contact. So I may cough or sneeze into the air, that comes to lie on a surface, or I'm infected and I touch a surface and I deposit that virus on that surface. The next person touches the same surface, may touch their face, and they can infect themselves. And then, of course, there's direct contact spread, which is person directly to person. We can't affect that, and I think the only thing that can affect that is social distancing. But for this indirect spread on surfaces, that's where the ion system can be another layer of protection. And that is, the ions will be attracted to that contaminant lying on that surface and perform this virus deactivation that I described earlier. So think of it as being another layer above and beyond everything that we're doing. We're wiping down and sanitizing things more than we have before. We're trying to be more careful about how we are protecting ourselves and how we're protecting others from potential spread. But now let's take something that is present around us all the time and touches every person and every surface in any space. Let's take the air and let's turn the air into a thing that can sanitize and not something that can spread illness. And that's what the ionization process can do. It can turn the air into a sanitizer to, again, continuously disinfect the air and those surfaces, which of course is a very important aspect. This is not something that I'm asking you to take my word for. This is something that's been researched and tested through many, many, many years. Our product in particular has been tested by third-party laboratories that have proven this effect and the ability to reproduce viral counts and bacteria counts and microorganisms, both in air and on surfaces, to a very high degree of efficacy, better than 98%. Also, air ionization does other things to improve indoor air quality. It agglomerates dust and particles and spores and takes them out of the air. That's been independently verified and tested. It also has the ability to break down volatile organic compounds, gaseous contaminants, things that make up odors and irritations. And that's also been independently tested and verified. And when I talk about these laboratories, we're talking about pretty esteemed groups, Syracuse University, Intertech ETL, ATL Microchem. The latter is a laboratory that does most of the EPA registered sanitization testing. So you're saying your product is 99% effective at sanitizing something. They're the guys that verify that it is. So it's a tested and proven technology that, again, we've applied quite extensively through many years. These are just some copies of actual test reports from the laboratory that validates and verifies your effectiveness. We also have some, and then this is a graphic too, I think will be kind of interesting, just to kind of put a visual to what the surface, the virus sanitization might look like. And again, if you look at those pluses and those minuses, those are the air ions that interact with that protein membrane, those little spikes on that virus that could, again, as you see in this graphic, puts a hole in it and deactivates it so it can't infect and it can't reproduce and spread in the body as a virus normally might. We have some pretty esteemed people that have looked at this technology, studied it, and validated in their minds its effectiveness. One person here, Dr. Philip Tierno, who was the retired head of epidemiology at NY Langone Medical Center, is now the professor of microbiology at NYU Langone. And actually, Dr. Tierno wrote a book called The Secret Life of Germs. And I would recommend in our audience, if you haven't read that book or you don't have it, get it. It's very interesting and extremely appropriate to today's environment. Dr. Tierno also was on Mayor Giuliani's task force post 9/11 during the anthrax scare, informing the biological preparedness aspect to what would happen if there were a biological attack in New York City. Dr. Tierno studied our technology. He's tested our technology, and he wrote a white paper talking about exactly what it could do, how efficacious it was. It really does a very good job of explaining scientifically, from the standpoint of a doctor and a virologist, what exactly it will do to deactivate viruses. And again, if you visit our website, AtmosAir.com, you can see that paper and other resources that we have. Just to kind of visualize what this is, well, there's a product submittal, but if you look at that device and you see it has a chassis and it has what looks like some missiles on the top of it or little torpedoes, those are the ion tubes, and those are the things that the airflow would go across, and they would spread the ions into the occupied space. So we take these systems, and again, these come in varieties large and small to fit all manner of air systems, and we adapt them to the airflow that the air system is delivering, the size of the space that it's serving, and the type of the space that it's serving, because not all spaces are the same. An office building may be different from an animal boarding kennel, which might be different from a smoking casino. And we have parameters for all those. So we adapt it to that space. And again, I'm just going to give you a little snapshot of what something like that might look at installed. So if you kind of look at these different pictures, we can put them in the main supply ducts. We can build them into part of the air handling system and integrate them in with a building's or a home's mechanical system that can, again, spread the ions all throughout the occupied space. The other aspect coming from an air testing company that we do is we monitor and validate our system's performance. This device you see here is an in-duct IAQ monitor. We can put that into the duct system and we can measure the quality of the air that's being delivered and the contaminant level that's coming back from the space, and that data can be available to the building on their building management system. We also have devices that can be put into an occupied space that a building or a homeowner can purchase, and they can actively monitor the contamination level in their space and track and measure what their IAQ levels are. We can furnish reports. We take these readings and we put them into perspective. How does your air quality compare with standards and guidelines and permissible exposure limits for the various contaminants? That's a big part of what I did personally in doing air testing. And so we provide this on an automated basis to our clients. So that's kind of, brings us to the end of my presentation. This energy saving thing, it's a little commercial specific, but there are engineering codes that can allow you to bring in less outdoor air and potentially save energy by applying air purification and monitoring and purifying the air. Probably less relevant in today's environment when we're talking so much about the health and the air quality in the building, but something to keep in mind. So at any rate, that's kind of the little presentation I wanted to share with you to kind of help you, educate you a little bit and visualize a little bit of what I'm talking about. I would love to open the forum up for questions, comments, or anything that maybe I could explain a little better.
Sure. Just turning my thing back on. There we go. Sure. Thanks, Tony. That was great. So I'd love it if you could actually pop up the slide that shows the machine.
Yeah, absolutely. Just go right to that. And so yeah, here's one slide which shows the device on in this product submittal.
Right. Now, the question I have is, so let's review with the group. So this works actually residentially and commercially. And this, talk about the size of the equipment and how it gets installed and how a solution like this gets actually deployed in the spa environment and also in the residential environment.
Sure. If you look at this device, again, it has 8 of these bipolar ion tubes. Now, this particular device is sized for 15,000 cubic feet per minute of airflow, which roughly translates into 15,000 square feet. So the first thing we do is we determine what is the size of the space and what is the air handling or air conditioning design. So if it has one air handler, sometimes spaces have many air handling units that are supplying air to condition that space correctly. We find out how many of those are, and we find out what their capacities are, and we kind of match these units up to suit. Now, we may have a much smaller unit that would have a single tube that might fit for your home air conditioning system. Most people's homes have between 1.5 ton to a 5 ton air conditioning system. Some larger homes may have multiples of those. But in any event, we can pair up a system with one or more tubes to suit that particular air conditioning system, which is, again, was sized to be able to saturate your home with conditioned air. How they apply is very simple, and I'm going to say this because I'm able to install one of these systems, so it must be painfully simple to do. But at any rate, you simply cut an access into the duct in the supply system, the supply side of the duct where the supply air is. and you insert the unit, you insert the tubes into the airflow. So if you look at this unit in the picture, there's a little flange on the unit. If you can imagine the unit, now maybe go back to one of these pictures. Look on the upper left here, the chassis stays outside the duct, and that's where the electricity gets connected to and the control gets connected to. But the tubes go inside the duct where the air is flowing. So as that air is flowing into the space, it gets infused with the ions. They come out the registers that are supplying the conditioned air into the space, and they infuse that space with the air ions. And again, it's the same concept whether it's a single hotel room with one unitary system that serves it, your home, or the terminals at the LAX airport. It's just when we have bigger spaces, we have more and multiples of these devices. But the concept is always the same.
So basically, HVAC or mechanical engineering companies do the installation. You provide the technology, and then talk to everybody about how the tech of the dashboard monitors the air.
Okay. We kind of monitor the air two different ways, and you're exactly right. We supply the systems and the technology and the support, and a mechanical contractor, an HVAC contractor would be able to install these and service them. As far as the dashboard is concerned, on the Atmos Smart Probe, which is this one, the Induct Probe, this is a commercial-only product. This goes into the airstream of the commercial building, and then that data is supplied to the building management system. Most buildings have a management system that takes in all kinds of data on their air conditioning systems, their lighting systems, whatever the case may be. And this will just be one more dashboard that they can add to that, where they can track, monitor, and measure their air quality. When we get into the space sensors, which again can be commercial or residential, these work by a cloud-based platform. So this device can use Wi-Fi, it can use Ethernet, and it reports out to the cloud, it sends the data, and then the user logs on to a platform that we have developed on that cloud where they can see that data and track it in real time. And again, we offer a service where we can monitor that data and we can provide them summary reports and kind of tell them about the status of their air quality and kind of compare it to standards and guidelines and really summarize what has been their air quality for a period. And we usually do that on a weekly period.
Okay, so I hope this question will be okay. So my question is, if I'm a spa operator and I have a locker room or a large common area, and I've installed AtmosAir in my ductwork and I have my quality report, and somebody comes into the space who's sick, say with the coronavirus, and they don't know it, how is that going to show up on the report? Like, how is that monitored, and how are we knowing that something's changed and then something's been remedied?
Okay. Well, one of the unfortunate things about monitoring or measuring for viral counts is that technology just doesn't exist quite yet in a usable fashion.
Okay.
You could sample for it, but you can't really track it. We can track other indicators of air quality. But one of the nice things, of course, is by seeing our laboratory tested results and also knowing that the systems have achieved the proper ion saturation, which goes into our engineering and proper installation and proper maintenance of the systems, at least when that person walks in, you have a layer of protection that if they are infecting a surface, that something can combat that actively in addition to what you're doing to sanitize that space.
Okay, I see what you're saying. So essentially what the air is doing is it's serving as a protective layer against anybody coming in. And because you're monitoring the air, you can tell that the quality is sort of kept standard at all times.
Yes, and also as we're monitoring that, we're monitoring our functionality as well. So we know that our system is functioning and it's doing what it's supposed to do. And we know if it's not functioning and not doing what it's supposed to do. And of course, that's vital information that as any operator, you'd want to know, because you have this protection in place. Of course, you want to know that it's functioning and it's giving you what you need.
Okay. All right, so we have a question coming in, and it's asking for you to go back over the cost saving slide.
Oh, sure. I'll just get to that slide. Okay, I'll kind of explain this a little bit. This is more of an engineering procedure. There's a group called ASHRAE, which is called the American Society of Heating, Refrigerating, and Air Conditioning Engineers. I'm kind of intimate with ASHRAE because I serve on several of their committees, and I'm chairman of one of their committees. It's called the SSPC 145. But what ASHRAE's done is develop ventilation and other standards for ways that mechanical systems are designed and operated in buildings. One standard they have is called Standard 62.1. That's titled Air Quality for Ventilation for Acceptable Indoor Air Quality. Sorry, I had to think about that for a minute. You'd think I would know it, but at any rate. So what that standard does is say to an engineer, in order to provide good air quality to a building, you need to design around these parameters. And one of those parameters is bringing in air from the outside. Since in a commercial building, you don't really have much of an option to open up windows anymore. So you have to mechanically ventilate the space. Now, when it comes to that, there's what's called a prescriptive code. The prescriptive code is, I have a certain building, I have a certain amount of occupants, I need a certain amount of outside air to subscribe to this correct ventilation engineering. And it's prescriptive. So if you have a gymnasium versus an office building versus an animal boarding kennel, they have different values. The amount of outside air per person you must engineer, and outside air per square foot of space. That's a prescriptive method. Another method is called the Indoor Air Quality Procedure, the IAQP. That is an engineered approach to the ventilation. This is also followed by a code called the International Mechanical Code. And that section of the International Mechanical Code is section 403, which deals with ventilation. And this specific procedure is called section 403.2 exception. And what this is an engineered approach where rather than give a prescriptive value to the outside air, you actually engineer looking at parameters like contaminants that will be typical to the space, what their generation rates are, what air cleaning strategy you're adopting, and what your ending contaminant levels are projected to be, and how do they compare against what is permissible from standards and guidelines that are produced by groups like OSHA and the EPA and NIOSH and other groups. So when you do that, it gives you the ability, if you're adopting an air cleaning strategy, and our technology is one of the approved ASHRAE air cleaning strategies, you can reduce the amount of that outside air that you need to bring in. Why is that meaningful? Well, outside air has to be heated or cooled or dehumidified in order to make it comfortable. The biggest part of energy in any space is just that. HVAC is the biggest energy user in any building. Actually, it's the biggest energy user in the United States. And the biggest part of HVAC energy is used to condition unconditioned outdoor air. So when you can bring in less of that and you can recycle air that's already been conditioned and you're cleaning it effectively, now you don't have to condition that much outdoor air and you don't need as much energy to do that. So if you can imagine the thermostat wants the air to be 70 degrees, but I'm bringing in air that's 5 degrees, and I need to make it 70 degrees, well, that takes energy to do that. But if I'm taking the air from the building that's already 70 degrees and I'm circulating it over again and again, I don't need quite as much energy to do that. And so by doing that, because you're cleaning it effectively, keeping with all of ASHRAE codes and guidelines, you can recirculate conditioned air and save energy. Some of that can be pretty meaningful. On a first cost savings, if you're designing around the IAQ procedure, your air conditioning system doesn't need to be quite as big. So there's CapEx costs. It could be as much as 15% on your equipment. But from an operating cost benefit, you can save sometimes from 20 to 40% on HVAC energy expenditures, which can translate to lowered utility bills. One project I'll mention in particular that we've done is the US Bank Stadium Arena, the entire stadium. This is where Vikings play football. We installed this system not because of air quality. They didn't really have air quality issues. They installed it for the energy saving advantage. And what they've seen so far is in less than a year, well over 6 figures savings in their energy expenditures, in the fact that their chilled water, their electrical, their steam, and gas is all reduced because they are now able to recirculate more conditioned air instead of having to heat, cool, and dehumidify a lot of air from the outside.
Okay, I've got some more questions coming through. So people are interested in learning about how this is, what the cost is. So for example, what would be the cost for, say, a 10,000 square foot spa setting?
Well, of course, there's complexities, and again, not every space by a raw square footage yardstick is the same. I'll give you a range, and that is, if you look at a range from somewhere from 60 to 90 cents per CFM, again, how much CFM gets engineered in space can roughly translate into 1 CFM per square foot, but that can vary, especially in a spa. Sometimes there might be a little more CFM because you have more demand to heat, cool, and dehumidify. But if you look at the roughly 60 to 90 cents per CFM, that's a rough ballpark of what we see as an installed cost with our technology.
All right, so next question is, what happens when doors or windows or sliding doors are open, and how does that affect the system? Great question.
That's a very good question. And again, we never tell people you shouldn't open your doors, you shouldn't open your windows and bring Lily outside, especially when you have days that are just right. It's something that's kind of an ingrained need to all of us to have a little bit of the nature's outdoor air. But with our system, we would like to try to control the indoor environment as much as possible. So it's better not to have doors and windows open because we'll keep the ions saturated in the space more effectively. We'll keep the air concentrated in the space more effectively. Now, some may go to how your building or your space has been engineered. A good space usually has what's called slightly positive pressure, and that is the air wants to push out of the building a little bit, not be sucked in from the outside. So when you have that kind of engineering, you're opening a door and a window, you still are able to exert some control over your indoor environment. Sometimes when things are reversed and your building's under negative pressure, you wouldn't be able to do that. That can be harmful in other ways too, because you're bringing in a lot of unfiltered, uncontrolled air that sometimes can be bringing contaminants into the space unbeknownst to you.
What about things like pollen and other pollution in the air? How does it affect the system?
Things like pollen, dust, spores, particulates, ions affected by a process called agglomeration. So if you can imagine, we have positive and negative ions, and it's very important to have a bipolar effect with balanced quantities of both positive and negative. But these ions will attract particles to particles, pollen to pollen, spores to spores, to clusters of ions. They all kind of agglomerate together. When they do that, the particle becomes bigger and it becomes heavier. Now, a bigger particle can get caught by a filter better. So by agglomerating particles in a space, your filters that you're using for your air conditioning system are able to operate more efficiently. They're able to catch more stuff because very small particles can slip through. In a lot of spaces, air was designed for comfort and efficiency, but not really designed for optimal air cleaning. A lot of dust and particulate may never get to that filter because it comes from the ground up. Just picture yourself walking across the carpet or into a room, And just maybe I'll put this in people's mind. Do you remember the character from Peanuts? I think it was Pigpen. He walked and that big cloud of dust followed him wherever he went. Well, when we do that, we walk across a carpet or in a room, we're kind of doing that a little bit. And also humans, we're dust creators. Our dead skin becomes dust and particulate. Some of that never gets to any filter in any room in any space. But if we agglomerate it, make it bigger, make it heavier, make it drop out of the air much more rapidly than it would down to the floor where it's less impactful to us and not where we breathe, that's how we can get cleaner air in our breathing zone.
Mm-hmm. Okay. What about maintenance of a system like this? What's the maintenance look like, and does the equipment have to be replaced or tuned up or anything like that?
Mm-hmm. I think that's a great question. And one of the things that we knew early on, and I knew from a lot of building experience, was that a lot of building operators, and even homeowners for that matter, don't maintain things the way they should. So the way we've designed the system through a lot of development and through some very good engineers that we've had I've had the opportunity to work with, is that the only maintenance that is required is every 2 years that bipolar ion tube that, come back to that graphic, that the little missile here needs to be replaced. Almost like replacing a light bulb. You take it out and you put a fresh one in. In the case where we have sensors, sensors are similar to the ion tubes in that every 2 years they need a recalibration or a refresh. But that is the only maintenance you're ever going to need with this system every 2 years. Other than that, it doesn't require any other human intervention.
Okay, so every 2 years. So that's really very, very simple. So it's just like a scheduled maintenance on any other piece of equipment that you would have in your operation.
Exactly right. And I mean, in our case, we track every tube that ever goes out of our factory to where it's going to. And we reach out to anybody that's bought our technology on the 11th month, or I should say the 23rd month anniversary, and remind them that their maintenance is coming up and they need to perform the maintenance on their system. And that's whether they're self-maintaining or if they're having their HVAC contractor maintaining. We just want to make sure they know that that maintenance needs to happen. The additional layer that we have is if the system goes far past its maintenance, well, at some point it's going to stop being able to function. It'll become disabled. And of course, then we'll know and the client will know that it's not functioning.
Okay. Okay. We talked about, you know, a size sort of estimate for a 10,000 foot spa. What about for a residential? What it costs run residentially? We have a question coming in. What size and cost for, say, 1,600 square feet?
For 1,600 square feet, you're probably looking at one single tube unit. Again, that may vary depending upon your HVAC contractor because they would need to purchase the equipment from us and resell it. But it probably could range anywhere from, I would say, $1,500 to maybe upwards of $1,700 or $1,800, depending upon your locale and also, you know, the contractor and what's their cost for installing the equipment.
Okay. 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 Well, this has been really great, I think. And does anyone else have any other questions out there that they want to message me? Feel free to. But Tony, thank you very much. I think this is a really incredibly timely and great solution. I know that one of the trends that we're kind of looking at in the spa community is this concept that when folks come back to using spas and hotels, they're going to want assurances that the spaces are clean and cared for. And I think that this is a really great tool for managing air quality. Sure,
and again, I thank you, Joanna. I appreciate the opportunity to share and to educate the audience. And again, this is something that Mother Nature developed, and I think the planet has answers to take care of various things about it, and this is one of those things. And what we're just doing is we're exploiting that natural ability to clean and sanitize the air for indoor spaces.
Yeah, and that is really what GSN Planet's all about, right? Kind of embracing all of the medicine that our natural environment offers us. So thanks for joining us today. Oh,
No
wait, I
problem.
have another question. One more question coming in.
Sure.
Can this technology be used in swimming pools? Wow, that's an interesting question.
That is an interesting question. Our technology, no, it's not meant for water purification. However, I am familiar that there is ionization technology
Oh
that
my.
can purify pool water. It's not something that we do, but I know it does exist.
I know it does exist too. I can probably help you with that. The person who asked the question will be in touch with you. Great. Thank you so much for joining us today, Tony. Really enjoyed chatting with you and sharing all of your knowledge about this product. Thank you.
Been my pleasure. Thank you for having me.
Okay, you're welcome. All right, everybody. It's a wrap on our webinar. Thank you so much for joining us.
Thank you.
Okay.